Good afternoon, everyone. Welcome to day 4, session 8, FPP on applications of AI techniques in modern power and energy systems. And today's speaker is Engineer SVS Panit Kumar CH, the BTech degree in Electrical and Electronics Engineering from Nagarjuna University, Nagarjuna Nagar, India in 2008, and MTech degree in Power Systems Engineering from Jawaharlal Nehru Technological University, Kakinada, India in 2012. He holds PhD degree with the Department of Electrical Engineering, National Institute of Technology, Raipur in India. He has accumulated 14 years of diverse experience encompassing teaching, solar power plant commissioning and testing and commissioning of power plant substation. His research expertise spans power electronics, machine design, operation, control and testing. This includes 2.5 years of industrial experience and 8 years in teaching and solar power plant commissioning and 4 years dedicated to research in power electronics, driver circuit design and machine design. He has a robust background in software tools such as ANSYS EM MATLAB Simulink, Flexen, Xylem Pilodo, DSpace Controller, LTSpice, PSCAD, Base, 3 boards, FPGA and PSpice, bringing a wealth of technical expertise to his work. He worked in various institutes as an assistant professor and was a senior site engineer with L&T's ECC division in 2012. Currently, he is a technical manager at E-Mobility Laboratory, L&T Technology Services, Bangalore in India. And please, and I request Dr. Panit Kumar sir to hand over the SAGAR.
Thank you. I need to thank DAYANANDA SAGAR University to invite me for this technical program. So thank you ma'am for my brief introduction. So we'll go to the present topic. So I'll lightly deviate from the topic and I'll get back to the topic back. So artificial intelligence. Before going to that, so we need to understand why we are going for the artificial intelligence. So how to implement the artificial intelligence with respect to the e-mobility sector, because I am not going to the power systems. So I am MTech from power systems. So my research, everything was gone with powertrains and drives. So I'll be more touch with, I'm comfortable with e-mobility AI techniques. So hope so it is not deviating much with respect to your FDB because it is power and energy. So because by I accepted, otherwise initially I given my non-compliance. So may not be it is possible with respect to the power systems exclusively with the AI techniques. So I'll go with the power electronics with respect to AI. So what are the advancements which they are into this e-mobility. So what makes the system to move towards artificial intelligence. So before going to that, so artificial intelligence. So why we require? So first I'll go with the question why the artificial intelligence is required. So I'll be more focused, as I said, with the e-mobility. So why it is required, an overview. So to smart battery management system, which is very much important with respect to the e-mobility. And real-time optimization. So what are all the optimizations that can be possible with respect to the development, design, motor design, power electronics, with respect to inverter design or else a DC-DC design. So that is one real-time optimization. And predictions. So we need to have predictive maintenance. So what makes the system bad in a due course of time. So this is also which we need to understand with respect to the this artificial intelligence that can be known from the artificial intelligence. and generative designs where we will be having more efficient AI trials, modeling, and intelligent charging. So when you say intelligence in the charging, so charging is a normal phenomenon. So where you connect your system, it will take as per the SOC and SOH. What is meant by intelligence? What makes the AI to penetrate into the charging sector? So we'll see that one. So one good example with respect to the AI with respect to the charging is, so because now globally there are many many standards with respect to the charging protocols, where we'll call as a CHAdeMO, CCS. India belongs to CCS mode of charging, and GB/T, Japan and a few other European countries will go GB/T. So when I get some vehicle from some European country, so you are connecting to your charging station. So your charger has to know what is your system. So it has to diagnose what your vehicle belongs to, which standard it belongs to. So accordingly, I need to have an algorithm which runs in the background whenever I plug in the charger to my vehicle. So it has to talk to your vehicle. So making that, so understanding that, so with that intelligence, so yes, this car belongs to some certain standard. So my charger has to get the voltages and currents as per that particular standard, because wide range of charging protocols are there from 200 volts to 800 volt system. So 400 volts, 600 volts, 800 volts. So in that, so AI plays a role how to distinguish which charger this car belongs to. So accordingly, I need to give the charging protocols to that particular vehicle. So this how we need to, so how that vehicle will understand, how the charger will understand. So this all can be possible only with respect to the AI. So what AI? So is that any new concept which we are talking about? No. So artificial intelligence is already, which is there in the market. Now it is got into the new format, making its own identity, making its own name, artificial intelligence. So this is all comes from the human intelligence only. So but reducing the efforts of the human, so we only trained that one. We'll ask them to work that particular machine to work in that particular format. So we only train that one and we'll leave aside so that it will be working to that particular what is meant, what is intended to be. So it will be working. So that is not a new concept which we can't we'll be seeing as a very big challenge to us. So we need to learn certain things. Everything we are learning already. So if we are, I'll say only one thing. If we are very strong in our basics with respect to all your what we are working for, so that itself is your intelligence makes how to develop artificial intelligence. So this all the digital scenario, what we'll be calling digital twin or else artificial intelligence, all comes under the same bucket. Machine learning, deep learning. So these words you are familiar with respect to the research activities and all. So you are much familiar with respect to deep learning, machine learning. So what this machine learning is? You are running with a particular requirement. So with that requirement, what is to be done? You only training that machine and making it to work in that particular. So with some sort of intelligence in that. So that means what is that intelligence which we are making to work with respect to that machine is. So it will understand what you are saying, what vehicle is saying, or else what grid is saying. So if you are going with the V2V, vehicle to vehicle communication. So how they will be communicating, how they will be talking. So that will be again with the protocol which you already developed. So that is not a big different scenario when we are talking with the artificial intelligence. That artificial intelligence comes from our human mind. So but now we are naming it as a separate portfolio as artificial intelligence. So that is only the thing which we need to come out, and the data driven. So you will have all the logs, do's, do nots, and what would be the constraint you will be getting. So you will make it every time you will be making its update. So based on your experience, based on that whatever the developed scenario is there. So if it is any problem comes in that particular thing, you will make that advancement and you will release the next version saying that, so this would, if this comes, you react like this. So and apart from that, it will have its own neural networks. So it will diagnose whether this can be diagnosed by me or not. So this is how you are creating some artificial intelligence to that and making it some memory allocation to that and making it to work along with your requirement. So that is what we will call as, and why we require. That's what I am saying, machine learning. So what are the things which we go with the machine learning? So how we can go with the compact optimization. So with the battery management system, so you will predict SOC. So whatever the state of charge is there, you will predict that one. So next, SOH, state of health of the battery, you will predict. So what to do? So do I need to alert someone? So if it is gone bad. So this all things battery management, if optimized charging. So let us consider now artificial intelligence in all your mobiles also available. So if you see Apple or else Samsung, so they already AI was penetrated into the charging scenario also. So it will run up to, so it will charge up to 90%. After that they will optimize the charging side. So charging time and current, everything will be limited. So how you have given that one? So that is all with respect to that, what is your application requirement, and apart from that, what is the system requirement. So based on this, you optimize your charging portfolio and you decrease the charging currents and you make the lifetime of your battery more. So one efficiency what we are getting, your battery cycles, you are not going to the deep charging and deep discharging. So even when you are discharging, so after below 20%, automatically what you will be having? So you will be having a battery safe mode, it will be activated automatically. Who says that one? So based on, so how it is monitoring? It is monitoring the SOH and SOC of the battery, and it will give, it has to go to the safe mode. And after certain cycles, your battery health was decreasing. You can even you can see in your Apple phones. So with, or else in AI also now, Samsung also has implemented that one. After certain cycles, the percentage of maximum charge or else available energy out of 100% it will be providing. So 98% of battery health is there. Only 60% of your health is there. So likewise, the vehicles also will have the same scenario, which it will be talking to the battery management system, and accordingly it will be preventing the, that's what, thermal runaway. So it won't make the overcharge. So that is one machine learning tool which already developed, that is also segregated as an AI. Next, energy management, as I said, balanced power, adapt to tariffs, enhance regenerative brakings. So this is the vehicle. Now we have tear down one BYD Seal car in our premises. So we identified certain advancements in that, sensors who are talking to the driver. So your door alarm will be there. So if you already cars will be there, and apart from that, 360-degree cameras. So with respect to all, it will alert your driver. ADAS. So ADAS is one of the now upcoming feature which already vehicles has penetrated. Now that was linked to your AI. So then it will drive on your own, driverless cars. So we'll call as level 4 car systems. So how it is going on? So how the driver thinks, we are making that machine to think in that way. So that is what the artificial intelligence what you are giving to your car. So let us consider an obstacle came. So the machine doesn't know what to do. So you are making that machine to learn, and yes, you apply the brake or else reduce the speed, give an give horn. So all these driverless cars are already implemented and it is connected to your GPS. So this is all how autonomous cars are working, means it is with the AI. So artificial intelligence. So how driver thinks, it will see the red light. So what it will know? So it doesn't know anything. So you need to make an algorithm such a way that if you see a red light ahead of you, you just hold on apply the brakes. So that is what the artificial intelligence, you make the machine to learn and make it autonomous. So simply, so make the machine to learn and make it autonomous, we call as artificial intelligence. So coming to the digital twin, how, so why? So this is one of the concepts which makes to optimize your modeling. So before going to the prototype, so what is the digital twin? So we will be with respect to the inverter and with respect to e-axle, what is, how the digital twin will work. So what is the digital twin? So we'll come to that concept. So inverter digital twin, when you see, so what it will be, it is digital modeling. So what is a digital modeling? So how the inverter works? You are making all that in the form of an equation, and you will get how, let's consider SVPWM you are getting. So if that SVPWM pulses you are getting, so how the voltages will be generated. So everything you will be making as entire system into equational mathematical model. So this mathematical model can be transferred easily to your artificial intelligence. So before going, as I said, so before going to any of the advancements, we need to have a basic concept how to see that particular concept in a mathematical way. So I say, so digital twin or else artificial intelligence is not a big deal if you are well familiar of how it is working in the form of a mathematical analysis, mathematical modeling of that. So if you see a motor, how it is working, so can you get back into the mathematical model and can you get analysis how the speed comes, how the intended torque is given. So if this intended torque is given, how the motor will behave. So if you back calculate and get the profile of your machine, so that you can train that to your artificial sector. So that is, you can train that one. This is my model. So you can give a command. So this is my model. Can you optimize this for particular voltage and particular speed and particular current? So this all can be done when the machine knows what is it sees everything in a mathematical way. So there is no beyond the word unless everything can be related to your mathematics. So the simple RLC, I can say all our electrical engineering or else any electrical engineering apart from the engineering, when you say electrical engineering exclusive has one concept of RLC load. So you can't go beyond this one. Any load can be segregated into these forms: resistance, inductance, capacitance. If you have a command in writing these equations, you can have your artificial intelligence in your hand. So how it works, you can identify. How to diagnose also you can identify. So that is what my first view of artificial intelligence, if you see. So artificial intelligence will start from how you think, how you train, what is your input, what is your output. So what is your intended input, you need to know. What is the intended output which is to be coming from that particular total subsystem or a system, you need to know. Then only you can say this is working or not. So first I'll go with the inverter digital twin. So real time, the physical inverter is formed into we call as a digital model. So you will model that one. So in the form of a digital equations. So that is what the digital. Apart from that, you will be making the total thing in a 3D modeling. So you will go for that. Once it is done, you will 3D model this. You will see where it is gone bad. So that is what if the machine, if you see. So that FEA analysis, what we are doing in ANSYS and all. That is nothing but it is internally it is doing mathematical equations only. And you will get how the flux is going on, where my heat is generating, where my stress of the machine is more. So everything can be, you can see in a visual way. So before going to that, what gone bad, how to tune that one, that also has to known by the operator. So that is why initially to going through this, I have just gone through as I said, I have just deviated from the topic. So I'll go with the induction motor, how to model an induction motor with FOC and DDC algorithms. So knowing this, how to develop a power inverter digital twin. So how to get out of this? So when you see, as I said, everything when you are saying it is a mathematical model, and all the loads are will see as inductive, resistance, and capacitance load. When you see that equation, it is a back EMF equation with respect to the one winding. So that first equation, when you see V is equal to I, so it is nothing but flux and resistance, and flux is nothing but is inherently which is present with the inductance. So that concept I have given. So I'll just go through very fast. So wherever if you are having any problem, we'll just stop there and I'll explain what is that equation and all. So that is the one is the stator voltage and the rotor voltage. Usually when you call as an induction machine, the rotor voltage will be 0. When you are having as a PMSM, you will be having a back EMF constant, that magnetical constant will come. So that we will call as some voltage will be left and it is not 0. So when you come to the induction motor, it is 0. So when you see that equation, from there you will be having stator field, rotor field, then rotor current. I'll give this PDF, don't worry. So you can go through that PDF whenever the problem comes or else any doubts are there. You just mark to that particular. You can ping me at any time. You can mail me. So I'll be just happy to answer, because in one session in 3 hours or 2 hours, I can't inject all the total concepts, and even maybe somehow it will be boring also if I penetrate much into that deep discussions. So I'll give the basic concept, how we are running the industry. So what we are seeing with respect to the digital twin. So what is the equation based modeling of inverter or a machine. So how we will see each and every algorithm in an equation. So this entire thing, if you see, so there will be no block sets, everything in the equation based. So we will see every machine operation or else inverter operation as an equation. So basically, if you are having a good command in writing RLC that instantaneous voltage equations, this will be, I think it is nothing. So as you all faculty, I need not explain much into that. So I just go through that, run through the slides. Wherever it is I need to highlight, I will be highlighting that particular point. Okay. So when you see that this is from the voltage equation. So I am getting one flux linkage equations. So where Lm is the mutual inductance and self-inductance. In this mutual inductance also, so you will be having a cross-linking of stator to rotor, because while that you will be having a current which is flowing through that IR is coming to the picture, and here also the same way. So and here Ls has two self-inductance and mutual inductance of that particular self-coil. So Ls is nothing but LL, LLR. So we'll call as self-inductance as my nomenclature will be LLR, and the mutual inductance will be LM, and together Ls is equal to LLR plus LM. So where you will be having a mutual inductance of self-coil and mutual inductance of cross-coil. So this is how you will be having an equation with respect to the inductance. So in the similar way, when you rewrite this equation, you will be getting current flowing through IR will be in this way. And finally, you are deriving and you are getting into single components. That means I am just making that more simplified to understand how the FOC is running. That's all. So it is not big equation. If you link from the previous, it will come as a flow. But if you see as an instant, it will be something clumsy. But I am just substituting with the equations which I am having in the previous, and I am trying to get lambda in terms of lambda R and Is. So I want only two variables. That's what I am just verifying. So accordingly, I am just getting the VR, Vs also, getting in the form of with only the stator current and flux. So what is my thought process of getting into the flux is, so to decouple the concept of flux and flux and torque. So because FOC is nothing but it will decouple the flux parameter and stator currents. So that is This is nothing but you will be calling as a torque components. So that's what I am saying. So when you are writing the voltage, so it should have either the stator current or the flux. So that is what my intention. I am just gone for the simplification. So similarly, you will be getting various components after deriving all this. So when I am aligned to our concept, so you will be having flux Bs is equal to Vds plus Vqs. So this is the direct axis and quadrature axis. So why I am going to for all this explanation is, so I want to make you to confirm that. So all the AI techniques when we are going for the artificial intelligence, it should be I need to train the machine in the form of an equation. And then I need to digitalize that, then I will need to train that machine. That is what the basic concept which I need to make this one. So then I have decoupled and I am having a cross couple. So that is what the decoupled parameter and cross coupled parameter. So when I say why I gone with the lambda r, so lambda r is directly I can say as that is a flux. So because lambda cube will have zero impact. So that is what I am saying. When I am orthogonally aligning myself the magnetical field, so my lambda r is nothing but lambda dr, which is nothing but the total flux in the machine. So that is why my main motto is to get to only two variables. One is the stator current and lambda r. So that is what I am just giving that. So I'll make this PDF and I'll share you. Don't worry about this because I need to introduce certain things, and AI is not a separate tool. So all that you need to understand every concept in the form of mathematics. So if you apply to the power systems, if you apply to the power electronics, if you apply to any of the things, AI is coming from your mind. So that you need to understand the machine language and your language and do the same platform. You need to bring it to the same platform so that your machine, your brain can go and imagine, but artificial intelligence will not imagine unless until you train. So that means you need to drive that one. Later it will go to the autonomous. So first who has to train is your human brain has to train, and that human brain has to understand what is the concept. Then you need to train that machine, give the autonomous nature to that. So it will work. So it will search all the clouds. So it will go to the internet. It will search for that. So whatever the question, whatever the things which you are getting, it will take the decision. But you need to make all this training should be done under the boundary limits. What you want. It should not be scattered as it like. That means when you say the artificial intelligence, so that artificial intelligence is dedicated to the work what you want, not when you say Copilot or else ChatGPT, what it is doing. So it is also AI, what it is doing. So what you want, it will blindly give answer. Whether it is correct or not, you need to understand, and you need to give that human feeling, human touch to that particular AI. Otherwise, it will think as a machine only. So there will not be any direction. So the direction which is to be intended, that you need to give. So first we need to prepare for the AI to invite to our world, and we need to go to their world, so that AI world, and you need to transit. You need to have your own understanding. So whether the machine is giving as required to me or not. So this is only the thing which we need to know. So otherwise, AI will be failure. So unless until we compete it, we are competing with the real time world which is running. So otherwise, even the teaching, everything will be going very poor. So unless until you adopt that one to the new system, new environment. So everyone is using AI. You will say that no, I will not use AI. So because AI is from me, no. So though AI is from me or else from us, it has own advantages. So you will start from the starting, but it will not start from zero. So you already trained that one. If you give what is required, it will start from there. So all of a sudden, if you ask if you want to switch over from one part to the other, you can't do. So let us consider I am working with some machine. If you ask me to switch to power systems, not possible. But AI can do that one. So vehicle to grid, now it is coming. So it has to learn the grid, it has to know, understand the vehicle, and it has to act accordingly. So it has to mutually handshake the signals. So everything it has to do and it has to work. So otherwise, no.
So please have.
Yeah. Five minutes break.
Sure, sir.
So what is the total strength here electrical is taking?
120. Two sections.
Any diploma candidates are entering in the lateral?
Yes. 10% two sections.
Candidates. How come this campus interviews and all? This time? This time market is poor. Even we stopped recruitment. After AI penetration, human. So we are inviting the technology, but we are killing ourselves. Now one man job. So earlier for all documentation or else some concept preparation and all, usually we'll assign to juniors who are just joining into the organization. We used to train them. So now that basic entry level jobs are gone with the AI. So the managers who are depending on the juniors for documentation and for few proposal making and few technical proposals makings. So that was gone. So now everyone, we also moved ourselves to AI. So getting readily available concept, getting all the basic things which are done by the juniors or as entry levels. We ourselves is preparing using the AI. So now that basic entry level jobs are gone, so everyone will ask from what is your experience. That experience will not generate unless until you take the freshers. So this cycle has gone bad after AI penetrated into the system. So now no student can able to say I got this much experience and I have recruited. I was absorbed by this so and so company. So there is no such. Now we need to see how to fill that gap. So there is no campus. Campus recruitment has also gone bad. So only the thing is that where very much requirement is there, only out of 100 we are taking only 20-25 members. So 75% recruitment was gone bad.
So if this is the case with some established companies like L&T, then small scale startups will be
Gone case.
completely.
No, that's what. So now, obviously in 2027-28, the middle level entry jobs also will be suffering because there are no freshers joined at this stage. 2-3 years experience, if you ask, after 2027, you will not get. Because that has to start from here 2025. So if you have a basic entry jobs, then 2028, 29 you will be getting 3 years, 4 years experience. But we are seeing in that perspective, going there, getting the middle level experience and candidates will be very difficult. So now, okay, we have solved because AI is giving as a fresher engineering who has to do, so fresh engineering who is doing, so that job is being given by AI. So after once that experience AI, whether it comes or not, we don't know. So again, someone has to work to get that AI to that mature stage, which will give the concepts as the 3 years, 4 years engineers will be giving. I don't know, it won't work. If you see, it will be a vague answers. So whatever the things are the basic concept it will give up to some extent, but not at the deep level. When you ask, AI will say something went gone wrong. You just chart with we usually because to make the test cases, even L&T has released a Copilot, Microsoft. So we are testing a lot. So whether it works for making some engineering works, so to avoid some recruitments and all, can we go with the AI? So we are going with the rigorous questions, so how the engineer is thinking, how what is requirement and all. We are posting a lot in the Copilot. So after certain answers, we'll get something went gone bad wrong. It won't give the answer. And if you want to have some concept, so preliminary textbook concepts and all, it will search from the search engine with the equations and all it will give. But not at the rate when you go for the deep questioning. So what is required for you? So I want a design. No one will do. So unless until you recruit the freshers now, how can a company make the design engineers? Not possible. I don't know. So where will go it will stop. So first the curriculum wise, what is my understanding is, so adopting the new technology, running behind the new technology is good, but it should not kill the basic concepts.
In new NEP also like that only.
NAPL has gone bad, AICT, I don't know.
They are not studying
so
the basic things only. They are based on
No.
their interest, student interest. They are offering that.
The student mindset is such a way that joining electrical engineering, why I need to have that much stress? So why don't I go for the machine learning courses and deep learning, data sciences, data analysts, and CSE, IT. So now core engineering level branches has gone bad. So but this will make an impact in the future, because the civil engineers will come who will construct the without cement and iron, they will construct the bridge. So that will come. So civil engineer and mechanical engineers will be there who will not do the structural analysis, and they will just manufacture their bridge structures and all. I don't know when I am just so I started my career with L&D ECC. Later I left the job and gone with teaching. So in the first starting class as a motivation. So usually what I will say, feel the engineering course. So what is the answer? Peculiar answer. What the students will say is electrical engineering cannot be feel. You can't feel the electrical engineering. So it is one thing is teachers and who are the head of the departments will be tough. So they will not give good marks. First of all, that was, and apart from that, they can't see the electrical engineering to feel. So the concept, everything is how you are imagining. So that time will not be there. How to make them visualize what is flux. If any student who is imaginative comes as, sir, can you say how is flux? What is flux? How flux will generate? So we don't have any answer. So we'll be giving only with Fleming's right hand, left hand rules. So we'll say that concept. This is a flux. You are having a current flowing through the inductor. You'll be having a flux. So how I need to feel the flux? Then that experimentation coming to the class was gone bad. So everything is a whiteboard. Mathematically, you are making them as a machine. So you are not seeing the physical scenario, what is happening. So unless until he see the physically, what is a flux? So whether you can get that galvanometer, you get the direction of current, you show that deflection. So you can't see, but you can feel, you can say. So that somehow the machine, if you say, that is a Greek language to them. So if you ask, what do you understand with the machine 1, machine 2, machine 3, they will say, sir, I don't know, I am just getting this concept to get through the examination. So that is what the answer they will be giving. So they will not learn the concept. And let's say if you this getting very hard to get the person who is understanding the machine. Nowadays in the industry also we are horrible in that situation. So there are all are power electronic guys who doesn't know what is machine is and they are driving the machine. So unless until you know what is a machine is, how you will drive? So they will say you get whatever the thing which is required, we will generate the pulses. So how you are generating the pulses? No idea. So if you make them to learn this one, they will not learn.
The converter part they are learning mainly.
There is no bridge. Now machine guy hardly will get the machine guy, hardly will get the power electronics guy. The person who can bridge the gap between these two, no.
That is like no.
So that is what the problem. So this machine guys doesn't know how to talk to the power electronics, and power electronic guys doesn't know how to talk to the machine. So unless until this happens, you will not run the EV. This is what we are experiencing in our daily routine services. So as we are more with the daily routine services, fortunately we are having a team, very good team with the machine understanding, very good team with the power electronics understanding, and we are diverse with respect to all these with the different OEMs and all. We work with Caterpillar, we work with BorgWarner, we work with Brusa, Dana, Danfoss. So, but fortunately, what they are also not asking to fill this gap. So, if they ask to fill the gap, gone case. So, the person now the engineers has to understand what is my requirement, what I need to do. That is missing somehow. So even the freshers who are joining, they all join. They want the 6 numbers, 10, 8 numbers packages, but not the concept. Really poor engineers we are seeing. So we are making them to learn a lot, but still it is not happening. They will show 1 or 2 years experience. They will shift to the next company. They will be getting some salary, and that likewise every time. Up to some extent, everyone is skipping. So means they are just passing their time. So the person who is working really to the concept, we are not able to get that one. And after AI, total gone. Now we are not relying also on the engineers. The managers, they themselves, what is required, we are preparing the documentation, we are sending. Somehow where it will go and park, I don't know. So that is a problem. So adopting a new technology is good because it is required, but for that we should not make ourselves bad.
Nobody is now what lack of AI.
Even that is true.
Within a second, if you want to sell something, you prepare and they won't prepare anything else. They put it on.
Even the student, what they will do, any question which is asked by the senior professors and all, they will type the same question in the air, whatever it is generating, you put onto the paper, they will get it.
That thing is going on nowadays. That's why they are
No, in NITs, this concept has gone bad because now they found this one. So last time they introduced this plagiarism tool into the assignments. There everything is an open book system. There is no only one exam will be there at the end, but remaining all assignments, everything is an open book system. So they need to submit the assignments. Now assignments will be uploaded to the plagiarism tool. So unless until it is unique, they will not get the marks. Then they will think of whether it is generated by someone or not. They will try to read that one. Avoid the plagiarism itself. They will try something. So somehow they are good enough, but still the Bird Engineering College, I don't think so. That concept was there. So same old slip test, same old assignments, and we will be having a final examination. If it is universities, same professors will be evaluating that, and I don't know. Somehow that the AICT has to penetrate into that, dictating some certain rules, but not at respect to this AI and all. So, to my surprise, few of the engineering colleges, they have opened the AI as one of the engineering.
Everywhere, everywhere, not only one, everywhere.
What they will be making them learn? Artificial. So, the course itself is an artificial.
So just opposite building only we can see the board, Department of Robotics and AI.
Robotics, okay.
Yeah, robotics is okay.
And
You can have that mechanical
and AI.
servo motors and all such things you will be getting. But what is that AI they will be learning? So unless until AI is specific, not AI is not open. You want your requirement. According to the requirement, you make that AI. It means if you say engineering course as an AI, to which direction that engineering course will taught the students, I don't know. So unless until you say this is my requirement, accordingly you can have some courses with respect to AI. AI again they will think as a CSE IT only and data analytics. So those courses only will be there.
Earlier, there will one course will be there, one or two courses related to the AI, data science or something else, design. But now they will make us a course for that.
Artificial intelligence means one neural network course will be there, which is Greek and Latin to everything. That neuron structure will be there. You will be having whatever the brain neuron structure will be there. The same will be there. Accordingly, you can map that this is my brain is brain cell. So what is the neuron? What is I remember that one is a very old it is. You will be having a nucleus, neuron stem.
Layers.
I don't know. But what is it? I want to know what is the structure also. Let us see what is the syllabus. So I saw in VT last time I was with SRM University. So there I saw that AI has one course. So this I don't know. So I'll go through the curriculum what they have prepared. Again, it will be targeted to some data analytics and this CSE and IT only. AI will not deviate from the CSE IT. I don't think so. But application based AI is required, not the bookish way of AI. AI is to be very precise to application. So AI with power systems. What can be done SCADA and machine learn that SCADA data and predict that what is the fault which is going to come. So then you train that if this fault comes, how to react to your relays and breakers, or else you diagnose this fault earlier to that, avoid that fault. So such a type of things can be done with the SCADA availability which we are having. Earlier at those days, SCADA is the first. After the SCADA with the intelligence called as AI tool which is coming to that. So what intelligence? So you will give all the scenarios, what would be the fault, diagnosis and all, everything you will make that learn and you will leave. Now what is the operator duty? One of the operator duty was gone and that job is gone. So I am seeing the penetration of AI with respect to the human. So you are losing the jobs. So penetration of AI will make the exit to many of the engineers. So entry level operators who are maintenance operators will be there. So that will be gone. That will be vanished because AI is penetrated. And for 2 jobs or 3 jobs, 1 engineer is enough because occurrence of events has reduced. And your duty has reduced and everything is monitored and SCADA is doing your duty and you are already trained the SCADA to attend that particular fault. Yes, we'll come back. This how we will be modeling the equation and you will be getting the torque. So that K dash is the torque constant. So where machine is required. So when I am designing a machine, this is very important. So unless until that, this is the part which you will be giving to the AI to tune. So what is my torque requirement, whether you can tune that. So with the intended IQS, so how much I need to get the torque. So that is how you will be having a modeling of that one. That is a block diagram which is showing the same, how to generate and all. I just make this PDF and this is how you will be seeing as entire system as an equation. So right from the starting to ending, so this even the inverter which I showed as a block, it is also an equation. So how you will be writing an equation of inverter? So S1, S2, sorry, the pulses which we are giving. So when you on the switch, so that is switch into your, so it is a mathematical equation. So inverter can be written in a form of an equation. If you try, I'll just give that here as well. So the pulse which you are generating and the switch operation. So together you can have an equation to your VDC. VDC is, so what are the voltage which you are getting at node A, means ABC if you are saying in 3 legs. So node A voltage will be coming from VDC bus. So VDC into S1. So S1 is your pulse width modulation of your first switch. If you are polytronics, you can visualize that 3-phase inverter. You will be having a 3 legs, 3 top legs, 3 bottom legs. So the phase A voltage, the voltage A phase, how you will be getting? So VDC is the voltage ultimately which is serving your A phase. So A into that S1, operation of that S. So is your the voltage at that. Means when you say voltage at node A will be S1 into your VDC. So this how we will be modeling the inverter as well. Even for the machine also will be modeled in the similar way. And you will back estimate this entire model. How you will be getting? You are getting from the machine model only. So what is IS? What is lambda? Torque? Estimated torque. Reference torque will be from your controller. Estimated torque is from machine. So entire thing you are generating as an equation. So once this is there, you can give this model to your AI and ask the AI. So this is my general equations. I want a machine which is having a voltage of this much, torque of this much. Can you calculate what is the flux? What is my ID, IQ and flux which is to be there in the machine? So it will generate and it will give you. So you are training the machine and you are asking what is your requirement. So but you need to give entire thing initially to the AI. Then it will give optimized result. So for every iteration, I need to go for each and every equation to generate. But once you are trying the AI, it will generate. So you need to give the answers, phrases. So this is my voltage, this is my current. So this is my intended torque. Can you generate what is the current which are flowing and what is the phase angle which is at this particular position of my rotor, what is my phase angle? Everything can be generated. So that is how I will be seeing that any of the thing with the form of an equation. Unless until you train initially, AI doesn't know anything. You need to train that one. Later you give the autonomous nature. So this is you already trained. So I want this, generate. It will generate. That is how this same block diagram. So how this transformation goes with an equation sinusoidal to DQ, then aligning yourself, it is going to the DC component. From again it is going to the machine, it will go as a DQ, then AC, and it will be going to the space vector. So this is how the transformations also will goes. So this all which I showed in the previous, this is how. So each and every aligning yourself to your means. So that is what the DC component, rotating reference frame. You are aligning your thing with the rotation reference frame. So how you align? AI doesn't know anything. You need to make that alignment. So that is how it will be seeing. So reference you will be giving, it will be controlling, and you will be getting the voltages which are generated to that particular instant. So and this can be given to your autonomous vehicles. Give it. So it will make to run. So this is my intended torque, and this is what my speed it has to run. So give the command that my vehicle has to run with a particular speed unless until any obstruction is there. So autonomous vehicle, so you will fix the feed, cruise control. So it is semi-autonomic, semi-AI. So what it will do, you will just give the accelerator and you will say that you just engage the cruise control, it will go in that particular speed unless until you are having any of the obstructions. So that is one part. How you are generating all this, you are giving the reference. You fix the speed, torque is fixed, your inertia is fixed, everything is fixed, and you are making the machine to load. So and making it to think and making it to more intelligent. So this is cruise control is half intelligent. It will see only the obstructions. And autonomous vehicle is it will take the entire data from your Google Maps, and it will be fixing all the speeds according to the road conditions you will be having. In nowadays, if you are running, so on the road, what is the maximum speed is there already? It is Google has already captured. So in this particular highway, 80 is the maximum speed. It will take that one. That will be given to your vehicle, and it will activate all the 360 cameras. So making all the sides, it will visualize, and if there is no obstructions, it will go, and it will follow the line margins. So everything will be, now you are making the system more robust. So first you are trying the vehicle how to run. Later you are integrating remaining requirements. So if my line is having a different means wide, so on the road, if you say continuous line will be there, so you need to train that vehicle. In this continuous line margin is there, you don't overtake. If there is a braided lines, means white line and there is a gap and again white margin, so then you train the vehicle that you can go for the overtake. So these are all conditions you need to give, so otherwise it won't know. So all the traffic rules you need to make them, the vehicle has to take that all the traffic rules. So red is there, amber is there, and green light is there. And when you see any obstructions which are coming, everything you are making that to train. And the road map will be given from the Google, and the 360 cameras will give all the objects which is in and around, and it will have its autonomous driving. So this is what artificial intelligence, where it will be coming into the picture. First, the concept started. I am just started with the very basics. How to run is the first AI. After that, you are training the controller, VCU, vehicle control unit, to run like this. Torque you capture from the speed intended from your Google map. According to the road conditions, you take 60, 80 kilometers per hour, unless until obstructions are there. You capture all the sensors which are in and around your door, 360 cameras. So when anyone is giving any indication, ambulance, when it is coming, you need to train that. When you have this type of vehicles, give side margin to them. So likewise, you need to train that algorithm. So otherwise, it won't do. So this, first you start with the basic, then you train the vehicle. That is what the AI works. Otherwise, so how the human is, that's what I am saying. Driverless car or else AI car, how human is behaving, how human is thinking, you need to make the VCU to think like that, vehicle control unit to think like that. So that is what the artificial intelligence into the vehicle. So I am just skipping the results. Similarly, DTC, how it will be there. You will be writing the DTC control also. This is also another control. Few of the Volvo is using direct torque control. Now they are moved to space vector direct torque control, SVDTC. So and FOC are the major all OEMs are working with FOC, because we have started with the FOC. Then DTC, SVDTC, Volvo is having SVDTC, and even Mercedes is using SVDTCs nowadays. So this is what the one more algorithm which the vehicle, again it is simple. So I'll give that PDF of this one. So how we are generating that. This is how the sectors with respect to the, you need to train the vehicle in all these sectors. So where to increase, where to decrease, where to settle my speed. So simply I will say that is this sector, if you learn, the DTC is completed. So increase the torque, IT is increase the torque, DF is decrease the flux. So the nomenclature was given already down. So wherever, which sector I am in, so in the 12 sectors where I am in, accordingly I need to map the vehicle either to accelerate or else maintain that, decrease the torque or increase the flux. So everything will be trying to that, and accordingly it will work.
Sir, yes, with respect to inverters, you spoke about it. Till now in all the vehicles that conventional that 650 inverters only they are using.
Two level. We are not going more than that because it is a very all the multi-level inverters is on paper. So I see many of these N level inverters. I don't know 99 level. What they will be doing with that N level and all. So still the market is saying simple 2-level inverters with maximum efficiency. That's all. And nowadays, as a DC bus is dictating us for excavators and off-highway trucks, where the DC bus itself is going through 3K, there we are going for only 3-level and 5-level inverters. So 0 stage, positive, negative, 3-level, or else do VDC by 2 VDC and 0 minus VDC by 2 VDC. So this 5-level inverters only we are maximum 5-level.
And PWM mostly space vector.
SVPW, space vector pulse modulation. Now everyone has gone. That signed PWM has gone. It was not. We are not using that space vector pulse modulation only. And that too min-max method. We are not going to the traditional way.
Okay.
So you can search with Kim Sul. Those who has introduced in 1985 or so. Scalar way of implementing the space vector modulation. Space vector modulation is not direct where you will be having a traditional way of generation. No. Min-max method, if you see, it will be the min-max method because it is easy to implement in a chip. So everything will be seen with the how to implement on a scalar way. So scalar modularity is very important. So instead of having a heavy mathematical modeling, so equation should be very simple. So min-max method, if you say, you will be getting that one. KIMSUL, KIMSUL. So that is so I'm just going same similar. This is how we generate. Even this is a hysteresis torque control and a flux control. And the trajectory of that one. Now you are coming to the digital twin, predicting the capacitors. So that this blue line is the capacitance real-time data, and the green line is the predicted data. So we are given on a DC link capacitor. So we are training the algorithms AI. So whether this is how much years it will be degrading. So where I need to change this one. So that is what the predictions, temperature, capacitor temperatures in all the operation, total operation of number of cycles were given. So this is what the total data will train that one. We will give the data sheet of the capacitor. So you can see that the capacitor is whatever the life cycle which we are making it. So the green line as it said, we are making that to run in a particular way, and all the data which is captured by the real time, it is mapping with the same. So what is the best out of here is, so we are estimating the temperatures in the capacitor out of this operation. So whether the estimated temperature which we are expecting in our trained algorithm is matching with the real time or not. So that is what the high pass filter. So that is the signal processing what we followed. Data required, capacitor voltage and temperature we have given. Then we have given to the high pass filter and VAC, and we have calculated. That's what equation based. Everything we need to train with the equation. So then VRMS and temperature we are giving to the LSTM model, and we will predict the temperatures. So in the over the time, actual versus predicted. So with this intelligence, a digital twin, we will try to understand what stress the capacitor will have. So whether I need to go with this particular capacitor also, I need to go to the, means before designing the actual inverter, we will take one data of the inverter, we will know what is the intended operation of my inverter, and we will train this artificial intelligence. We will train that particular machine. So this is my operation, this is my capacitor operation, whether it is mapping my requirement or not, or else any spike or else any deviation is there. You can see at that particular starting pulse at this my what do you call predicted is following some way, but artificial intelligence couldn't capture that spike in the temperature. So at that corner, so that is actually predicted has gone with a very bad. No, this is the prediction. That's what I am saying. This blue line is the prediction. So at this particular intended operation, we predicted that it has gone bad, but in actual scenario, it has not gone because mathematical equation doesn't know what is sudden or else not sudden. So that predicted value has gone bad, but not the actual. Actual doesn't have that huge spike. Temperature will not rise at a overshoot. This where the human intervention will come. No, this won't happen. This will work. So we need to give that one. So machine algorithm will give. There was a notch over there. It has overshooted the temperature, but in the real time, the green one doesn't have that one. So that is what. So there will be some deviation because equation model and the real time model will not match anyway. Even the artificial intelligence also will not match. So if you train also, how much optimized way you train also, it won't happen. So dynamics is dynamics and your study is study. So dynamics will never have any match. So that what? Every time you need to update. So update. So if you see in this scenario, you update in your algorithm. You will see in the next scenario, update in the another. So due course of time, it may converge. That is also no guarantee. But all this will help at least not to have much failures. So failure rate will be reduced, but not the failures. So unless until failure come, you will not update the algorithm. So failure rate will be always reduced, but failure will be there. So predicted value, actual value, predict value, actual value. This is how we will be plotting all. So in the similar way, we are trying the lifetime estimation. So we will give all the equations, predicted lifetime of each, how many hours, how many cycles. So we will predict that this particular component will be used for this many cycles. Capacitor will be used for this many cycles. And everything you can see. What is intermediate composition? So everything you are calculating with equations. So unless until you know the behavior of the capacitor, how many cycles it is running, how it is voltage bus is varying, so how your pulse width modulations are varying, how stress is there on the capacitor, you can't write that equation. So unless until you write that equation, our machine will never know what is the operation of your capacitor. So that's what. So artificial intelligence I'll see in a different way. Artificial intelligence make us to learn, but you need to open your window. So artificial intelligence also requires engineering works. Engineering efforts are required. So this particular thing, if the teacher, student and the industry knows, then only it is a sustainable growth will be there in the industry. So saying that I am having artificial intelligence, I can do. No. So artificial intelligence is not a Greek and Latin. So artificial intelligence always come from the basics. So I need to know. So up to now I have seen the capacitor. I know the equation of that capacitor. So now what is the application of the capacitor? If you think, a student can think, what is this application? So in this application, how much stress this capacitor goes? How much temperature cycles this capacitor goes? If he predict, if it goes a step beyond, thinking process will change. So obviously again opportunities will come. But if you say that everything is there, why I need to learn? That thought process itself will give you full stop. So every time I say only one thing, learning is a comma, there is no full stop. So every time you make that comma, so invite one small breath and take the next sentence. So if you put the full stop, gone. Nowhere you will be having any of the next step. So your sentence is ended. So but for every comma you need to open one window. So how to start back the sentence? So that breathe, in that breathe time, you need to say the student. So unless until AI is there, good. Unless until you know the basics, you can't do with anything with the AI. Up to now, initial usage it is okay. So it won't give, it won't generate electricity. It won't generate food for you. It won't generate cook food for you. Everything should be done. So I want a cook. So AI robotics robots are there where the China is manufacturing. So they will be giving all the how the ingredients to be used. What is the cook what is the ingredients which we need to use for the cooking process and all. This is the process which you need to follow. And the robot go there and that will be cooking food for you. But who has given what is the ingredient, how to cook, and what is the product? What is the product out of that? The human only. So instead of starting you do, make the others to do in a proper way what the requirement is and what is your intended operation is. So unless our thinking process has to change. So thinking is good, adopting a new technology is good, but thinking process should be opening the windows to the new technology and how to adopt that one. That is also one scenario. So how to take that AI into our daily activities. So with strong basics. Unless until strong basics are there, nowhere.
I have a doubt. So first, in suppose induction motor modeling we are doing in MATLAB will be implementing and will be analyzing. How these things were done?
These are also in MATLAB only.
MATLAB.
Yes, this window is from MATLAB. MATLAB is having that tools.
We are getting.
Yes.
I thought in some other.
No. This entire thing, even this is from MATLAB.
But how we can use AI?
Yeah, I'm saying that's what. AI is not a new thing. You make that everything as an equation based, and what is the requirement for you? You train that one. So you need to give that one. Artificial intelligence program is something different. Application based artificial intelligence is something. I am not going to the programming level of AI. I am going to the concept level of AI. So this predictions, everything will have its own algorithm. So this equations VAC, VRMS. So how to give to that particular tool also, that is one programming tool which you need to adopt. So if you see the VRMS, it is a normal equation. So that equation you need to write in your embedded C programming code which is there in your MATLAB. Embedded toolbox will be there. So there you will be writing and you will be training that this is what my requirement is. This many cycles I need to run. So that is how the temperature, this is my load profile. Everything you need to give. Then it will predict this is what my capacitor temperature profiles which will be generated over a period of time. So in the similar way. So that is what the delta T, TC predicted. VC will be giving and remaining lifetime of your capacitor it will be giving. So what is the lifetime of your capacitor which you use for the DC link? So this is for the analysis which we did for DC link capacitors. So we'll give the values, we'll give the number of cycles, we'll give the operation of that one. It will give what is my lifetime of your capacitor. So this is artificial intelligence. So and you will be giving a source impedance. So to your inverter. So DC link current will be there. So then you will be having the same force Fourier transformation and your harmonics, and you will be having a defined thresholds, and you will be getting that what is the actual VDC and a threshold which is of 40 which we are giving. So this is how you will be predicting the VDC. So this is the red line which we are predicting, and this is the threshold which we kept. So you will be able to get, so what is the source impedance, whether prediction is happened or not. So we started with the balanced VDC, and it has almost having a threshold, and it is source impedance was detected. So green dashed line is the analysis one. So there is a source imbalance. Finally, this prediction has settled over there, and it said there is a source imbalance. So again, everything is with respect to mathematical equation. So unless until you know the mathematics, it can't be predicted. And in a similar way, load imbalance. Yes.
Data you are given. The calculation you are given. Second.
This blue line is a prediction.
No, we are talking about the block line.
Flow chart.
What is the calculation? We have DC, suppose we take some DC link voltage. And that putting the below stand.
This one you are saying. So data required is that one.
Yeah, that I understand. What calculation is?
So what is the requirement? So as per based on that, IABC will be calculated and it is given. It is not a real time which we are giving feeding back. So we calculated that. So this is my load profile. Accordingly, this is my IRMS, IBRMS, ICRMS, and accordingly we will be giving to this model. So this is all with respect to prediction only. It is not the real time data which we are capturing. So in future, prediction. So prediction is one of the part of AI. So
Suppose we have some data, suppose we take we want to know predict the capacity. So you measuring the voltage and capacity current.
yes, that is a real time what you are doing. You will diagnose what is my operation of buck converter. You will predict what is the current which is there. Based on the equations, you will get the IABC value, IDC values, and you will give this one model. You will give to this model. So diagnosing the real time data is hill, hardware into, and giving and diagnosing that.
No, create model again.
Yes. You need to know what is the load profile. According to the load profile, what is your current and all, you will back calculate and you will give to this model. So this is not the real time data which we are having. So this is for inverter what I am saying, IABC. So what is your machine requirement? You will know what is the currents which are required for the machine to that particular operation. You will calculate what is my IA, IB, IC. You will give to the model and you will see that whether there is a load imbalance or not. And you will define what is the imbalance. You will define what is the imbalance. Whether it is predicting that imbalance or not, you will be giving. So this is how usually that is the difference. So artificial intelligence means your prediction. Before getting, you are predicting that, and you are getting what is IA, IB, IC with this imbalance. Whether your algorithm is able to map that prediction or not, you are training your algorithm and you are leaving. Once it is mapping with the real time, so you will create the same with the real time, and you will map that one, and you will give the prediction to that, and you will map that one. You will coincide with both. Whether those two are mapping together or not, how much error I am having with the calculation and with the real operation. So this is how we'll be first initially making that machine to learn.
So initially synthetic data.
Synthetic data will be there. One is from the model and one with the real time. We'll map again. We'll verify. So how much error? Okay, this calculation has gone bad. So where it has gone bad? Again we'll train that one in a proper way again. So once it is mapped, say that yes, whatever the real time operation of my DC-DC buck or else boost or else inverter is there, yes, my trained model is trained enough to predict what are the things which we are having in the real time operation. So everything is, one is real world, one is artificial world. You are creating that environment and you are verifying that whether you are achieving the real environment or not. So one is imaginary, one is realistic. So this one is a calculation, and the calculation is given to the LSTM model, and that LSTM model will give the output. So actual versus predicted, you will plot. Yes, there is a deviation you can see. threshold, actually with you are crossing that one. So your prediction is slightly having some deviation with the actual. Again we will try that one. So we will try to minimize the error, or else we will give, yes, with this much of threshold, my trained model is able to predict the total operation of this DC-DC converter. And this is your one artificial intelligence of your DC-DC. So this model can be used for predicting all your algorithm. You can optimize, you can design your optimize, you can optimize your design. Everything can be done with this model. That is what the this actually we are doing with. We are dealing with. Similarly, the capacitor current prediction. So in the inside the capacitor, how it is. So we will give the capacitor currents. We will predict with the VA, VCR, LSTM model, and actual versus predicted will have. So slight deviations are there. So whether it is accepted or not, that will be decided by OEMs. So in the similar way, you will be having a capacitor ripple factor prediction. So trained versus difference. So even for the battery, so charge, SOC, everything will be predicted. You will be trying cell level parameters will be there, experimental data will be there. Parameter, you will be creating the cell model into the MATLAB. This is all entirely can be done in the MATLAB. So MATLAB can be possible. So all our EVs majorly we are doing with neither MATLAB or else ANSYS. All the machine modeling and all. FEA analysis with respect to machine, everything will be doing in ANSYS or else Siemens FEA analysis. So and remaining all our control part, prediction part, and everything will be done in MATLAB. And one MATLAB exclusively for industrial MATLAB and educational tool MATLAB is having some deviation. Again, I am just stressing. So you will not have all the tools which are used by industry. So proprietary license will have different, with the education level will be having a different, and ours will be having a different model-based developments will be there in our scenario. So here in educational we will not get a model-based development. Otherwise, MATLAB won't get a revenue. So almost for 1 year we are spending 15 to 20 lakhs, and our proprietary license itself is 15 to 10 lakhs for all the lifetime. So I am not wrong. MATLAB with respect to which they are offering for institutes for 5 license, 25 license, nearly 20-25 lakhs, 25 license you will be getting. For 1 license for 1 year, we are spending 15 lakhs. So there will be a difference. Similarly, degradation, estimation with the battery. So this is how we will be having a 2-level, that's what. Simple 2-level inverter only we are using. Simulation with respect to flux, then we will be integrating your motor and all, we will see what is. This is the first we are doing with the diagnosis and prediction and everything, and we will go for with the Python environment also we will verify. So one is with the MATLAB simulation, inverter simulations and flux. So what we will be checking all these algorithms with almost 3 levels. One is the first inverter we will do with the Simulink. Then loss analysis everything we will be doing with the flux modeling of that. And Python programming is also possible with respect to generation of inverter model in that. So this is how. So I am done with respect to this. So this is how. This is what I said. We have head of the BYD. Component wise we did the analysis. Out of security reasons, I have just like that 18-month system as. I did disguise that one. So this is the architecture with respect to power distribution. So finally, once the AI is done, everything predictions, everything gone good, then we will go for the architecture level. So then we will go for the what is your requirement with respect to real-time architecture and all. Then we will be having so inverter control algorithms. So then deep level, component level. Inverter components. So then this is 2 supplies HVDC and LVLV. So you are having. So I just explained. This is very interesting because for every each and every power system, e-mobility will be doing the redundance part. will not go with the cost as a criteria. So for every voltage of your board, I need to have one, if one phase, I need to be having a backup readily available. So this is what it is doing. One is doing from the high voltage to low voltage, and the other one is saying from the LV to LV. So one is the main supply. You are calling this as a loading. So this diodes will have a higher drops. So one will be giving more voltage at this node. If one phase, this particular node will be 0, then this diode will be forward bias. This is what we are calling as a O-ring diode. So we'll play everything with the diodes only. So this is the one, and this path is for ignition. Initially, to have to wake up this PIN unit, this has to be driven by this one. For wake up of this itself, we are having one more signal which is double diode. So which will be giving some certain voltage here. Once the voltage comes from here, this voltage will be higher than this, and this will be reverse bias, this path will be off. So this is how we will be managing the powers with respect to the wake up signal and redundancy. So everything we are just playing with the diode principles only. One diode will have more drop, the other will be having a less drop. So here, once the voltage comes here, so one of the diode will be reverse biased. If one path has gone bad, so this path will come. And initially to arm this one, there should be some voltage. So this buck will be given by this control will be given from this buck control. This PWM has to come from to the buck converters. These two, fly buck or buck, that is given from here only. We to wake up this one, initially supply is not there. Then one more addition came to have one initial supply here. Once this is buck is on, then this is through, and this voltage will be high. Then this path will be break. So you see, for one implementation, 3 levels has gone bad. So that is how we will be playing with the power electronics with the simple basics. So it is not a hi-fi, same simple logic how we are. So if you get that in your teaching, so it will be more helpful for the student, because even I kept this into the slides. So you are learning the diode, but what is the application of the diode? How we are playing with the drop in voltage? Forward drop is also having some importance. So that 0.7, 0.5, 0.71. So selection of that drops is also having some importance. So then you will be having an O-ring which is formed here. So this is how it will be usually. Then this is how finally, once the artificial intelligence stage, all the prediction stage there, you will be mapping with the what is your requirement and what is your yes, this is my selected component, this is my selected pin, and finally this e-mobility will come into the picture. So I'll stop here. So if any doubts are there, we'll just have an open discussion. So otherwise we'll wind up. So I'll just brief you what we are doing. So this is what our NTS EV laboratory where we are established. It is opposite to the Asia Mall when we are traveling towards airport. So it is on the highway of that. So we, as I said, this is the powertrain test bench. It can be operating from 340 kilowatt to 340 kilowatt test bench. Motors and inverters can be tested on this bench. So this is nothing but your laboratory, what do you call, generator and motor generator set. But it is having a 4-quadrant operation. So with the high sophisticated controls and all. So similar test bench where you will be having motor inverter test bench and some controls out of that. So we are having 2 of them. One is of 40 to 340 kilowatt. The other one is 1 kilowatt to 22 kilowatt for 3-wheeler and 2-wheeler applications. It is entirely 4-quadrant operation. That is what. This is the smaller one, 22 kilowatt one. So 4-quadrant operation. And means regenerative braking also can be tested onto that. And even generating mode, motoring mode, everything can be tested. That is how this is so done. Yes. So hope I am not fast, because usually my teaching will be slightly fast. Greek and Latin will be there, so some feedback from the students also it is there, because that was not improved. And after a long gap of 5 years, I am again on to giving the lecture.
Thank you so much, sir. Your session was very insightful and it was a very good learning for all of us. So if we have any question, we can just...
Yeah, open discussion we can have on half an hour or so. So any general... Which one? Yes. Inverter and DC-DC, we are having a dedicated team who is working for distributed. So they will predict all the components, take the data sheet, they will prepare the model-based algorithm out of that, and they will give, yes, this component is good or not. Because OEM is having that, means that is one of the requirement where OEM is seeing that, so whether the selected component is okay or not.
Sir, one more doubt. So your mathematical modeling of that component you are doing, how you are connecting the data, digital twin, how basically you are creating?
Digital twin is not a, as I said at the starting opening remarks also, it is a digital form of any component. When you are transferring, it is a digital twin. So either inverter or as a motor, if you are making that as a digital format. So where you know what is the operation, you will give that algorithm, this is my operation, and you will train that whether it is operating in that particular required intended way or not. So, and one more digital twin modeling is predicting the lifetime also is one of the digital twin. So you are having a capacitor. So you will give that capacitor basic requirement and how it is operating. So what is the means you need to generate what is the stress which is there in a physical working scenario, what is the stress on that capacitor. So that again you are giving the equation model of that, and you will say that yes, this is my operation of my total life cycle. So in a compact way. So you will not use the entire 500 cycles or 600 cycles in a seconds. So you will make that 1 day as 1 second. So accordingly you will run the algorithm in such a way that, so every second how the variation, because your window is in your hand, so the 24 hours is converted 8 hours is converted into 1 second. So you will give the profile of that particular operation. So you will give that cycles entirely, which is the intended operation of the capacitor. You will get that what is the log which is going, and you will predict also. So one prediction algorithm also will predict that yes, this is, and you will have the real time data along with the predicted data. One will be on the real time equation based model. One with the one will be with the equation based model. What I am saying, the other one will be the Simulink model of that. So one will do the Simulink modeling of, one will do the equation model of, so and we will compare. So later we will take these two data and again we will have a real time hill environment. You will get the same scenario in the hill also. We will map all these three. Then we will go to the real time production. So we will pass the thing in 3 layers. One is the equation based, then Simulink based, then hill based hardware in loop, then we will get to the real time. Yes.
You are not doing data.
Data is one thing. Data is the equation based data modeling is one.
Physical fundamental basic equation based modeling and completely will collect the data. We create a model.
This is what the first one, which they will collect the data. We'll create one model. We'll get that data as to be executed. One Simulink based model also we will do.
This default to existing component.
Yes, with the default. We'll map that one. So the physical data, if you are having any gaps, so how the capacitor is stressing with respect to the operation, Simulink data will also plot that one. So we'll see that whether the collected data which is there is similar or not. So any corrections are required. So everything is to train that digital twin model. So all the three ways will execute the data and will make our data itself is concretely given to our digital twin, equation based model. So then we'll say that so it has passed all the tests, this is okay, and we can go for the execution level, means we can go for physical modeling of this one. So hardware, prototype. Then again in the prototype also we'll collect the data. We'll feed back to that. So whether the prediction and the operating data are matching or not, or else dynamically how much a threshold is there, how much a deviation is there. So this is how we'll be. So it is not in one cycle. One cycle can't be say we can't say that one. It will be means my model is correct or not. So it is a cyclic way. So finally it will come and converge. Yes. Now the digital twin is ready with respect to DC-DC buck. Now the digital twin is ready DC-DC boost. This is how we will be doing.
So then each part, each block of the whole system has to be separately.
Yes. Then entire system. Entire system prediction where it gone back cannot be predicted very easily. So it should be component based analysis. So then each component has completed next component. So everything is working fine. Or integration level again they will be having challenges. So there that predictions will be difficult. So if component based that is not passed through. So if I go and integrate to the integrated system and trying to get that what is gone back, no one can judge where it has gone back. So yes, this component is giving good results. So now I am having all the data with respect to that component. So in the system level, if anything gone back, so I can go to the data. So where it has gone back, which operation of my intended operation has gone back. Then I can go and map which component in the integration gone back. So reverse mapping also will be easy. So first I will get the total data of one component. Next, third, fourth, which are all the means DC-DC charger, onboard charger, inverter, motor, everything will be correct. Charger will have no impact on the vehicle level of operation. Vehicle level operation will have DC-DC, inverter, motor, and VCU, and thermal management system and battery management system. So and power distribution unit. So these are the 7 main thing which we need to verify with respect to the operation. So if I am having individual data, so I will get that yes, this is my VCU is intended to operate this, but my inverter is not operated this, and I will verify whether this scale, this process already we have implemented somewhere or not. If it is not no, so we will train my algorithm and I'll go back there and verify where it has gone back, and I'll do this. This is my operation. So I'll see where the inverter has gone back. So means this is all entirely as a cyclic process. So we'll go with the physical model, Hill model, Simulink model, equation, digital twin model. All the 4. So data handshakes will be there, means you will collect the data real time, and again we'll put the same data for the training. So whether I am getting what is the operation which is intended, whether my equation model is digital twin model is giving that particular thing or not, or else the equation has gone back. I need to go and verify the equations whether it is, so where it has gone back. So I predicted the operation like this. If that prediction is not, means that equation is not giving that prediction predictive value, I need to train that again. I need to add some more loop, or else I need to verify. So where it has gone back. So everything is a cyclic process.
So there are certain modes with which we can leverage the EV applications, like it is V2G, it is V2H. There is one new concept which is now originating, that is V2X, that is vehicle to everything. So whether it is just an extended terminology for this previous ones, or is it something?
No, vehicle to X will come only. It is a concept level.
Okay. Only origination.
Just it is something means. So as I am having a power source already, why don't you use for different applications, different appliances? So for that, your system should be ready. So unless until your system is ready, you can't. Yes, power is there. You are not having an intermediate integrator who can connect to your load. You get to that particular level. If it is not there, vehicle will be there, your system will be there, but no one will be there. No one can use that one. Now vehicle to vehicle itself is still in a concept stage. Vehicle to grid, somehow it is materialized because bidirectional power supply DAB, DAB systems are coming, double active bridges. So that topology made the system to go for the bidirectional power flow and all. That vehicle to vehicle vehicle to grid we have tested for one of the OEM. So one of the one DC-DC onboard charger was tested for that. So we verified to grid and we pumped the power from this side to that side to this side. We got all that bidirectional flow. So that now it is in the implementation stage because this vehicle to grid also came because of the uneven tariffs. So that is US is having the dynamic tariffs and all. So all the total 24 hours it won't be the constant tariffs and all. So you will be having a demand side management we'll call in the power system concept. So based on the demand, so your prices will change. So what they will be doing, whenever the prices are low, they will charge the battery and they will maintain. It is one part of revenue generation. So the other, but our grid is not ready for that. Our Indian grid is not still ready for that. So even solar is also not at a complete full stage you are using. And the charges which the solar which we are giving, which we are paying for the grid is 10 rupees and which grid is paying us, it is only 3 rupees. There is a huge gap. So there it is something different. So here it is something different.
What is that? 10 rupees, 3 rupees?
Means for solar selling price and grid selling price to us will be 3 rupees. So when we are selling any power to the grid from the solar, they will be paying only 3 rupees. And when you are utilizing, they are charging us 10 rupees.
One more question, sir. Whether battery energy storage is required for PV or not required? Is it
EV.
means solar power?
Solar power. You can have your grid integrated systems. That is means you can not require. Batteries are not required because even you can have a grid tied inverters. You can connect to directly grid. So you can utilize.
Utilize, but any
No, that's what. In a month of a cycle, you need to be always plus. It means consumption should be higher than generation. Then what you are saying means you are in a profitable zone. If your generation is more than consumption, if grid want to pay, you are losing. So let us consider. I will say in a different way. So your demand of your house or else some construct some industry. So your captive power generation of your solar is, let us consider 400 units. Your utilization is 500 units. Then you are plus. Because 400 units you are charged at the rate of 10 rupees. When we are trying to sell that power, it should be balanced both. 400 units utilization, they will not agree. So at least you need to sell or else you need to utilize. If you are in a utilization stage, your plant is in a profit. If you are in a selling stage, your plant is in a loss. So that is what your grid is not paying much for us. So our grid is only paying 2 rupees 50 paisa to 3 rupees.
2 rupees every time it will be very
It's not a data.
solar great tariff is solar power. So this way, sir, consumption and generation data each day, sir.
No, over a month your generated units are plus or negative.
That means generated units are negative because consumption is more.
That is then your plant is in a profit. No, I installed in my sorry, I was not shown that much, but I could log in here also because there are some firewalls which are installed. So I have installed 1 megawatt plant in my old college, VR Siddhartha. Still I can monitor here, I can control my inverters. So I am giving my extended service because that was registered in my email ID and my phone number and all. Still the college, after the 10 almost, I left the college for 6 years, 7 years. Still any fault with respect to comes, it will come to my email ID and it will give a fault message. So this inverter, grid tie inverter has gone bad. So I need to alert my head of the department in a revert mail. So you send some technician to see that inverter. So this is how we will be monitoring online. So almost 1 megawatt plant was installed in my college. It is SMA inverters from Germany. So each of 50 kilowatt. So that is nearly harvesting 150 kilowatt of it is harvesting almost in a thumb rule. If I say 1 kilowatt can generate 4 units a day. 1 kilowatt of power, solar plant, if it is harvesting 4 units, how much is your harvesting? How much kilowatt you have kept?
4 kilowatt.
How much it is generating per day?
15 to 16 minutes.
4 into 15 to 16, right? Then
Sometimes 17.
no, on an average I am saying, or the harvesting period of total 365 days, your plant should generate 3.5 to 4 units. Otherwise, it should be kept under maintenance. So 3.5 to 4 is good enough.
Since this difference is the 10 rupees, 3 rupees, battery if we have, that will be profit to us.
No, battery itself will be having more problematic. You need to only cycle. I'll say only one thing, ma'am. So cycle of your battery is only 4 years. Okay, so over a period of time, you need to change the battery at any cost. So that investment cost will be more than what you are utilizing. So unless until you are not having a floating pseudo battery, batteries with respect to solar power plant is waste. So pseudo batteries, your grid is already there, pseudo battery. So it will be sourced and it will be synced. So that is there already. So you can sync and source from grid only. So unless until you are not having that pseudo, then standalone solar plants, if you are installing, then battery is only the criteria which we are having to install. Otherwise, no. So solar plant will pump whenever the harvesting is there. So we will call that power as an harvesting power. So whenever the harvesting is there, at that time, real time utilization should be there. As it is abnormally moving, there should be some mediator who can make that as a constant voltage and constant voltage source. So it has some voltage fluctuation, but it is a current source. Solar will call as a current source. So it has a voltage fluctuations as well, but the current source will not see what is the load requirement. So it will generate as per the solar harvesting, and at that particular time you can't maintain that much of power. That is also not possible. So let us consider in a fraction of a second your sunrise will be very intense. So it is not with respect to the heat. It is with respect to the photon energy which you are having. So that photons are high. In that case, your harvesting will be high, and at that time you are not maintaining the load. Then that power, where it will go? Generation is there, demand is not there. Then if battery is there, it will take the battery as a charging unit. It will charge that battery. If not there, you can sync to the grid. If grid is always there, if your inverter is a grid tie inverter, that is the best way. So maintaining the battery will be headache for us. But EV there is no other chance. So lithium ion batteries which we are placing in, and it is also having its own problem. So I'll say simply, even I am in a EV powertrain, out of the box its camera is off, right? So yes.
Camera off.
Remove that. Stop that.
I couldn't meet you all having all this discussion and all. Sorry.
So we'll take on.
Just a minute. Marikanda sir, I shared this PPT.
Yes, sir, I will.
I have shared that PDF of this PPT.
Yes, sir.
You can share that.
Yes, sir. I will.
Stand.
Yeah.
That's the process.
It's here, it's recorded. Stand and we'll take. When I action,
ಕಿರಣ್ ಪವರ್ ತೆಗಿಲ್ಲ ಇದು
You are in which college you are?
ನೋಡ್ಬಿಡಿ ಇಲ್ಲೇ ಬರುತ್ತೆ ಪರವಾಗಿ
There I did my UG, sir.
You DIT, right?
Yes, yes, yes.
My sir is also alumni of yours. He's very old, right? But yes.
ನೋಡಿ ಮುಂಚೆ ಸರ್
thank you so much, sir.
Yeah, share that photo. Madam, who is your